Our last example here is looking at quotients of powers of sine and cosine. So we've only looked at products up to this point. We were multiplying and taking things to a power, but we can use those methods for some quotients, not all of them, but for some of them, if it involves sine and cosine or secant tangent, and also then cosecant cotangent, right? So your three pairs are sine with cosine, secants with tangents, and cosecants with cotangents, right? Those are the combos. All right, so let's look at how this is done, and I'll talk about that sum in just a bit. Okay, so for this integral, I'm going to rewrite this. This is sine squared of x over cosine squared of x times, and there are three of them there, so times the sine of x dx. Technically, you don't have to write the over one part, but I just wanted to make it very clear. Okay, so why did I do that? Well, because that is equal to the integral of sine squared over cosine squared, of course, is tangent squared from the tangent identity. So I really have tangent squared x times sine of x dx. And if I have tangent squared, well, then with Pythagorean identity would be 1 minus, oh, sorry, secant squared. I always get those backwards. Secant squared x minus 1. And if you're sitting there thinking, how would I know to do this? You don't know to do this. You play around, right? You start playing with identities until you find something that's going to yield something useful. That's what you do, right? So you just keep messing with it and messing with it and messing with it until it gets somewhere good. And it will. It's just going to take a while. Okay, so this is so good so far. I mean, we haven't broken anything. This is correct. So now I'm going to distribute it because the minus sign part, let me rewrite it. If it's secant squared of x sine of x dx minus the integral of sine of x dx. I kind of did two steps at once there, right? I distributed and I'm separating my integral because this one, I can do this integral. This is not hard. It's cosine, right? Or negative cosine. So it'll be negative cosine. So that'll be easy over here. Now this part, I still have to keep working at it. So secant squared of x is really secant times sine. So this is really a secant of x, and then secant is 1 over cosine, right? And that's based on the secant identity. Times the sine of x dx minus, and again, I'll just leave this integral out here. I mean, technically I could find it. It's up to you, right? So if you want to write plus cosine of x, then that's fine. If you want to wait and do all your integration at once, that's fine too. Whatever makes you happy. Okay, so now why did I do that? Well, because sine over cosine, these two together, again, that's tangent. It's the same identity we used up above. So this is the integral of secant of x. Oop, if I can make an x that looks right. Secant of x. Tangent of x. And that should be setting off little bells in your head because you know that integral. Minus the integral of sine of x dx. Secant of x, tangent of x, we know that integral, right? That integral is one that's from the basic sheet from Calc 1. It's right here. So it's secant. So this is number 16 on the quick reference sheet. And for the record, sine of x is number, it's in there somewhere, 8 on the same sheet. So we know both of those integrals, which is our goal in life, to get to one of those integrals we know. So this is the secant of x plus, so it's minus the negative cosine of x plus c, right? So that would be the secant of x plus the tangent of x plus c. Now we were able to make this work and fiddle around with all of this for one particular reason. And that's where the word sum comes in. If you'll remember, back at the top, right here, it says, I'm going to put it in pink actually, it says sum quotients right here, sum quotients. So what would those quotients be? What would they have? And the reason we were able to do it, if you look at our particular problem, is the extra sign that we stripped out was in the numerator. If it was in the denominator, it wouldn't have done us any good. So sum quotients means that we need to have the ability to strip out or factor out, ability, there we go. I can spell, to strip out a numerator value. Like in this case, we stripped out an extra sign, right? That extra sign, we pulled it out of the numerator, right? And it has to be in the numerator to make it work. Extra function, such as sine of x, or secant of x, or tangent of x, or something like that. And I'm just going to put ... right? In this case, we did sine of x. But it has to be in the numerator in order to make it work. If it was in the denominator, if it was sine squared over cosine cubed, it wouldn't do us any good.